Hello and welcome to Simply Technical. Got a new guest, one of Keaton and I's friends. Like I said, I'm Evan and this is Keaton. We're your hosts, as it always is, and we're going to continue what we talked about kind of last week of medical, just the subject of the medical field, whether it's diseases or innovations. Dave here is in med school right now. And what kind of doctor do you want to be, Dave, if you know?
So I'm thinking about doing something with surgery, but I've just started med school, and so it's really hard to say right off the bat what you want to go into. So a lot of people change their mind along the way. So having like a set idea from the get-go could lead you to some disappointment and really kind of close some doors that you might want to leave open. So I'm kind of leaving the door open at this point.
That's good, because you don't want to say, okay, this is what I want to be, and then I didn't know about that, and now I kind of set myself up for the wrong path, I guess. Is that kind of what you're saying?
Yeah, or just, maybe I decided I want to focus in really hard on neurosurgery, which some people might do that. And then, I miss out on opportunities to look at other things like pediatrics that really I would have been happier doing pediatrics, but I just said I'm not even going to
look at that.
I'm not even going to explore that this might be something that would be fun for me. And then later in life, I could look back and say, well, I wish I would have looked at it because I hate my job now.
Let's hope you don't hate your job.
Burnout rate is about 50% for physicians, so
that's ridiculous.
It's very high.
That's ridiculous. Why? Do they ever talk about that at med school? Like what they can do to change it? And
they do talk about it a lot. It's a really complex issue. A lot of people have just really high expectations of what they're gonna do, and we're really unrealistic, not knowing what the field's gonna be like. And I think a lot of it is just being really idealistic and thinking, this is how my patients are gonna be. That they're gonna respond really well to the way that I want to treat them.
Yeah.
And then you really just don't get to the root cause of a lot of issues for a lot of people. But then there's this other issue of a lot of our best medical interventions don't help very many people, which is something I learned. Well, here we go. We jumped into a topic.
That's good. That's what we want.
So something that I learned about early on that I didn't really know. I didn't have a background in medicine in undergrad. I was actually an electrical engineering major. So I know a tiny bit about that world as well. And I also know about changing your mind halfway through, which is why I'm leaving more doors open
Same.
on this path. But something that I've learned about really early on with pharmaceuticals is there's this aspect that they call number needed to treat. Have you heard about?
I don't think I've heard of that.
So if you ever read a study about, they call them like an evidence-based practice.
Oh yeah.
So most of them, if you look and you'll go back and see this if you ever revisit one, but they will have the name of the medication, what it treats, and then they'll say number needed to treat of X. It will be, It's usually, good ones are 5. What that means is with that intervention, if you treat 5 people for it, it's going to fix 1 person.
Oh my gosh.
And that's a really good number needed to treat.
And this is a pharmaceutical, or is this a surgery-based
actually any
approach?
It could be any medicine or surgery or even just exposure. So what they would call it, so you could have by the same mathematics, you could find number needed to harm for something like smoking.
Yeah.
So if you avoid smoking, if 100 people avoid smoking, you save, a lot of them actually.
Yeah.
So that's a bad example.
Whatever,
probably
the odds of lung cancer.
Yeah. The number needed to harm of smoking is actually really low. So if you honestly two people smoking, one of them is going to have a really bad problem from it.
Yeah. It's interesting. So, but that, I guess, is that in, how do I say this? So I know when it comes to pharmaceuticals that it is extremely rigorous to get through the FDA.
Mm-hmm.
But in that aspect, like in the idea of 5 people and only one needs to a 20% success rate, that doesn't really make sense. How do these drugs get through the FDA if the guidelines are so rigorous?
Well, there's a few aspects of that as well. So one of them would be we have nothing else to treat something.
Yeah.
And the more severe of a problem it is, the more likely it is to get through with a number needed to treat of 100.
Yeah.
Chemotherapy, for instance, just because it treats something terminal, you might as well put it through, even though it's going to hurt a lot of people, and it's not going to work on many of them.
Yeah,
sadly.
that's true. That makes sense.
And actually, something about that, we have a professor at med school who has a doctorate in biochem.
Really?
And so she had told us the other day that when you're looking at basic science, the basic science that we're working on now, those are the medication targets that are going to be around in 30 years from now.
Yes. Yeah.
So she said she has actually a specialty in protein folding.
Oh, okay.
And the things that they were working on in the 80s are just rolling out now.
Yep.
So that she was on the cutting edge of back then. So
that takes a long time. Goodness.
Yeah. But what if we follow Moore's law and eventually we're just pumping out new technologies? Because I guess to explain, it's like the exponential growth of technology. So as you discover more technology, that new technology helps you push through newer technologies faster, and so on and so on. Is that similar for medicine, or do you think it's more of like a linear equation?
It's probably going to have a big effect because we're just now getting into, for DNA sequencing, for instance. Yeah, we just got like a full genome in the early 2000s. Yeah, and so with the technology with that is advancing so fast just due to new algorithms and computers. I mean, we've only had computers since the 70s. Yeah, and so we're talking. She had, even from her observation, that was kind of her observation with the 30-year thing. That's probably different
100% believe that too as well, though.
But I mean, since she was started in the 80s, computers were started in the 70s. They were pretty useless at the time. Yep. Comparatively speaking. Yep. But then now with advanced algorithms, as long as we can
it's new AI and
figure things out, if we can figure out the software, we have the
science, the biology.
And we do have the biology, I think. But
that's, to me, that's like a big hole in research. It's like this idea, like people are discovering stuff at an alarming rate, but there's no one that's like at or not no one, but there's very few scientists that are taking these discoveries and then putting them into practice. It's all these, I mean, they only take the I guess the high likelihood success ones rather than the lower end ones, and I feel like there's a lot of missed opportunities with new drugs and new treatments when it comes to that kind of stuff.
Well, and that's the other problem, is that with rare diseases, if you have a rare disease is considered something where less than 100,000 people in the United States are affected. Yeah, that's a lot of people. That could be a lot of people with those diseases, 100,000 people, but you're rarely going to have unless it's something simple that you can fix, which I don't think it ever is. Yeah.
Not anymore. The simple ones have been found. Yeah. Yeah. For the most part.
I mean,
I don't know. I think there's a lot of very, very simple, huge diseases that we can't figure out yet, or we figured them out, but we haven't been able to implement a treatment.
So what kind of diseases would that be?
That would be kind of like, I don't know if anyone listened to the last podcast, but the big three, the cancer, cardiovascular, and neurodegenerative. I'd say cardiovascular and neurodegenerative, or cardiovascular predominantly, is
simple, or
not simple. It's complicated, but it's not quite as complex as the others, I think, because cancer's different with everyone, and then neurodegenerative, we still are having a hard time understanding, because first off, it's hard to cross the blood-brain barrier as it is, and the brain is just so dang complex. I mean, I think we've had multiple drugs fail for Alzheimer's, and I think if they had any sort of efficiency and effectiveness, they would have been pushed through. But so it's kind of mind blowing that probably dozens of drugs have failed to do anything.
And that's because they don't know the mechanism really of Alzheimer's, and we're looking at that right now in class. Some lectures, and the lectures half the time they're saying, and we don't know why that is, and And really, so what the definition of Alzheimer's? Do you happen to? It's probably useless knowledge, but so the definition is this dementia with amyloid plaques present in certain parts of the brain, and so amyloid plaques, that would be these misfolded proteins that get aggregated all into your neurons, and since neurons are one cell that doesn't ever reproduce, really, it doesn't divide. Like your skin cells, for instance, you get new skin cells all the time, but your neurons are pretty much there. So when a neuron dies, it's gone. And so really that makes your neurons more susceptible to this misfolding problem and really a lot of problems. So when you have when you're malnourished, for instance, the first thing you'd notice in a lot of patients, the thiamine, for instance, is vitamin B. Mm-hmm.
Is that B12?
I think it's B1 actually.
B1, okay.
But you'll notice neurological symptoms really fast just because these are some kind of susceptible cells in your body. What was the question?
It was it was. I mean, you kind of answered, or it was more of just like a discussion on what Alzheimer's is and how do we treat it. Yeah. And I kind of could go off that a little bit because the whole amyloid hypothesis has seemed to fail when it comes to treatments. Because we've taken out the plaques, but it doesn't reverse Alzheimer's, which is mind blowing because we haven't found any other correlations. Right. So it's not the causative.
It's weird.
Case of Alzheimer's.
And that's actually what I was getting at before I lost my train of thought. Is that really you see amyloid plaques build up before you see any neurodegeneration, like years before, decades before even. So
it's kind of like the whole the cholesterol and LDL building up in the arteries from as soon as you're like 12 or something, and it just
it's now it's us. This is the only time we can really do anything about it in our lives.
It's almost
sadly.
Like, to me, it's just like a time scale thing. Like it's inevitable, but how do you slow that process down? And that's kind of, I mean,
you prolong when it's going to happen.
It's the idea of aging,
right?
Which I think is almost every disease out of the big, not every disease, but all of the big three that kill people is how do you slow the inevitable cancer, the inevitable neurodegenerative and cardiovascular disease.
Well, that's a complicated question as well, because what you would think is avoid stress at all costs.
Yeah.
Because really we're talking about these diseases, they're pretty much all caused by problems that are going to develop later in life due to your DNA replication causing something goes wrong, or you get a mutation, and then you have a clotting problem. So now you're building up more plaque in your arteries and getting a cardiovascular disease. Or with the amyloid plaques, that we're not sure what that is, but we're pretty sure it's just some late stage genetic problem that just starts to aggregate as you aggregate more mutations or whatever is happening.
Makes you wonder what like the evolutionary purpose of these mechanisms were, because it almost as always there's like a protective function being served by most things in the body, but it's like when that protective function is overexpressed is whenever you start to get these diseases present, such as inflammation. Like every single big disease is related to inflammation in some way. It's the big double-edged sword of our human biology.
Cancer.
Yeah, all of them.
And also strong correlations to type 2 diabetes.
Really?
Insulin resistance.
I didn't realize that.
Both are highly correlated.
Okay.
So
but what came first, the chicken or the egg when it comes to that kind of stuff?
And who knows, but could be all three.
Yeah.
But back to what you're saying about the protective functions. So we know the protective functions of inflammation. Obviously, whenever you get a splinter in your finger, it has some kind of virus on it. Your body can isolate and get rid of it through the inflammation. Chronic inflammation is weirder.
Yeah.
Because it's different mechanisms. It's a totally different system. But it does work in like healing
There's a healing
long
process
term.
to it.
And less efficient healing, more scarring, fibrosis, which is what
Bad news.
healing.
Bad news.
and that's what would cause all the pain in your joints.
Yeah.
So you have this chronic inflammation, but it's really a different response than when you have an acute, which just means fat, like it sets on
Yeah.
all of a sudden, sort of. An acute infection. So we know the defense mechanism of that. We don't really know the defense mechanism of telomeres
Yeah.
for aging.
Yeah.
Unless, do you know that? Do you happen to have a theory?
Well, I don't know. My theory is that telomeres are the whole telomere shortening thing is kind of a. My theory is that once the telomeres are completely shortened, well, that it happens because at that point you're probably not able to reproduce. So what's the point of you being on Earth as an evolution from an evolutionary mechanism?
And you're using up resources as an older
person. But then on the other side of that, the flip side of that argument, humans are different than other species because we are so tight knit. We have the family unit, so it's important to have older people. So you can make the same evolutionary argument from both sides. So it's still, to me, I don't want to.
From an emotional standpoint, you want that person there, obviously.
Yeah.
Right.
But from a survival of the fittest standpoint.
Yeah, but not everything's survival of the fittest because there would be no such thing as what is the word for whenever you are kind without a reciprocation?
Altruism.
Altruism. There would be. What's the point of altruism outside of, I guess, ulterior motives?
It would be to help more members of your species reproduce as a competitive factor against other species.
Okay.
Maybe.
Yeah,
Perhaps.
that's possible. That's possible. But what were you going to say about telomeres shortening?
Well, I think what we were talking about is more interesting, but
No. Well, shoot, let's go on. I could go on about the whole evolutionary dynamic. So there's this thought experiment with altruism. So people can say, most people who are extreme evolutionary biologists say altruism is there because we all have ulterior motives. So the people that are like survival of the fittest, well, you're only being altruistic is because there is a part of you that realizes your altruism is going to cause you to get something better. So like when people donate to political candidates, they're only doing it because that political candidate's going to be some push-pull. But the candidate doesn't have to do anything. So can be kind of considered an altruistic. A donation is an altruistic move, but without reciprocation, but in that context, you're expecting some sort of reciprocation. The most stringent evolutionary people are like, well, that's what all altruism is. And so I was thinking about it one day, like, what about people who donate anonymously? How does that work with those people's ideas of altruism and evolution? It doesn't. To me, I've never been able to make sense of that. It kind of seems like there's something deeper about why we do good things.
I mean, I guess in some instances you get a good feeling of it makes you feel good that you, like if you donated anonymously to a charity,
yeah,
and you didn't do it for tax purposes, you just did it.
Did
it for you because it makes you feel good. I mean, that would be another.
Yeah.
Those good feelings, could be a biological mechanism.
Yes.
And would be some sort of, and maybe all that is to give you that good feeling, the biological mechanism, to give you the good feeling so that, because your body knows more than you that more often than not, altruism is reciprocated.
Yeah.
Or good karma.
It's getting kind of weird.
Yeah, it's
getting a lot of
we're
abstract.
Almost in Sam Harris's no free will idea right there. Oh gosh,
and that's a tough one.
Yeah.
Have you ever? Oh, this is a really hard for some people discussion. I mean, not like it's gonna make you emotional, but a question for you guys to determine A test to determine if you believe in free will. If I took an exact clone of you right now and sat you across the table from that clone. So the clone, that would be, they have all of your thoughts and memories. Everything you
up
have
to that
on,
point. Up to that
all
point.
your exact same molecules in your cells.
Up to that point.
Mm-hmm. And you're facing each other in a symmetrical room. Could you beat yourself in a fight?
Well,
You want to go?
no,
ahead.
you go first.
Okay.
You-
Well, I was just gonna
you haven't
say.
been talking.
I mean, obviously, I'm biased towards myself. Even though that person is exactly me, I'm biased towards myself. So yeah, I'd win. But I mean, it's not like you. I guess could you knock each other out? I mean,
Yeah, and so
Yeah,
and if
it'd
you
be
did,
almost
then you
even-
couldn't beat. I would count that as a tie. So I would say no, you didn't beat yourself.
yeah. So
So if yourself is yourself, then who's really winning?
all right, we're gonna end it here, guys. Thanks for tuning in. I have some things to think about. I mean, like I said, I'm biased towards myself, so I'm like, oh yeah, I could beat anybody in a fight, but but I know realistically I couldn't. I mean, I would think it'd be a tie. Like, I mean, statistically, but I mean, somebody would have to win. I mean, I guess you have luck on one side. Like, one side would end up being luckier, and just an RNG kind of situation.
So that sounds like you don't believe in free will. But so I guess it
Don't
depends. Well, so do you think the RNG, the random number generator,
Yeah,
is would that be in your own mind, or would that be in so if
it's
because
just like a lucky shot. I mean, if you, I think, if say you fought against yourself 10 times evenly,
Sure.
I feel like you would win 5 times,
Yeah, that makes sense.
and the other your clone would win 5 times.
Interesting. Because what I was saying though about the
Does that
random
that beats your test?
no, that means
I'm
you
so
do.
smart.
I think you do believe in free will in that case.
Because I mean, if it was just like one fight, I mean, it just I would think that RNG would. Somebody has to win, and I mean, I don't think. How often do people knock each other out in a fight? I don't think that happens very often. If you both just swing at the same time, both right-handed, and you knocked each other out, I feel like the human error would come into effect in that.
Sure. Yeah.
That's
So
where
I guess
one of you would make a mistake.
If one of you
yourself.
made a mistake, then you have free will.
Yes. One of you would make a mistake, and somebody would have to win.
I 100% believe the same thing.
Okay.
I don't
I mean,
know. Maybe
I believe
I don't know
in
if I
free
just
will,
flip flopped on that, but
No, that's
I
exactly like
Definitely believe in free will, but I'm not educated enough to make like a strong philosophical argument about it. Now, that's actually something I kind of want to like read more about in a couple months.
maybe we'll have a podcast about it.
Eventually, once I'm
We'll ask the exact same question in a couple months.
do it.
Wait, what would you say?
I don't know.
That's why he was asking, Keaton. Come on.
Like I can't tell. I think I do believe in free will in that sense. So I guess I do believe there is some kind of random number generator in your head that would allow you to make 2 different decisions
Yeah.
in the same situation. So I really think I do believe that
Yeah.
one of myself would win that fight.
Yeah.
Because we'd make a different decision in the moment.
Part of me almost
even when
thinks
faced with the exact same stimuli.
Yeah, part of me thinks that a portion of free will is emotion, sort of. Like, that's why we almost have emotion, because if we were purely, like, instinctual...
Analytical.
Like, do animals have free will? Like, the lizard, Russell, yesterday. It almost... like, it's just neurons firing. It has no emotions. It almost seems like that lower level system doesn't have a say in what they're doing. It's just all instincts. But there's like a component of emotion in humans that most of the species don't have, or we are fully developed at, and it really makes no sense why we would have emotions outside of bonding with children and family.
Oh, you
So-
mean from us? Okay, go ahead.
I was just gonna say.
Other than
So what? Like, say in a zoo atmosphere,
yeah,
you have those same animals, but say they're raised in captivity. They have completely different instincts. Is that because they were just born in captivity, or do they still have the exact same instincts?
they still have the exact same instincts, but they're not as honed because
They're
as soon as you release them into the wild, most of them will die.
So I was thinking. So when I hunt, I like to hunt. I
Yeah.
hunt deer. When you're in the wild and you're hunting a deer, say you're just sitting on the ground somewhere and a deer, you make a movement, it's going to run away.
Yeah.
But near where I used to hunt, they have a fence of animals, like, or not, I say animals, of deer, just there. The deer will walk up to you and let you feed them.
Yeah.
Is that instincts of I want food, or because they're scared of you, but
yeah, I guess. Okay, so this isn't something I've like thought about. I'm kind of just doing it on the fly right now.
That's how all our podcasts are.
So yeah, so fear is an instinct, but
you can overcome that, I guess.
There's a suppression of fear with those sort of animals, and they don't understand. Also, I think they're mammals, so they're more highly evolved, especially with the brains. I don't know if like a lizard would ever really be comfortable eventually with humans. It's kind of just like.
So I watch a YouTube channel. What's it called? Chandler's Wildlife or something like that. And he has a bunch of snakes.
Yeah.
I don't like snakes, but for whatever reason, I like to watch. Maybe it's because I'm on the edge of, is he going to get bit? Is he going to get bit?
Yeah.
But he has snakes, and he has them in captivity. Some of them he got from captivity, and others he's caught in the wild, or somebody caught in the wild and he bought from. A lot of those snakes still have those instincts. Like if they're caught in the wild, they're still hostile towards him. He still has to be careful.
Yeah.
But like snakes that he bought, so like he has a couple, I think, green anacondas that he just got from captivity, like weeks old, like a week old. He can like pick them up and like have no worries about them. Like, I mean, they're constrictors, but not that they're poisonous. So he doesn't have to be as careful. But they're so docile, and I don't know if that's just because they were born in captivity or.
Yeah,
because that's a lower. That's not a mammal. That's a lower species, like a lizard.
Yeah.
So the ones caught out in the wild, and especially in the beginning, he has to be very careful with them because he doesn't know how they'll react. They have different, almost moods. Not that they have their own personality.
Yeah.
I mean, some do just because of their experiences, but most of them act the same way. So
the ones that are raised in captivity are always born more docile.
I don't know about always. In this case, for these green anacondas,
because they don't have to kill to survive, I guess.
Anacondas,
yeah,
or
like if they're
the snakes born in captivity, they just get fed food and they kill it there.
Yeah.
I don't know. I just thinking about, because that's a lower, I guess, evolved species, even though it's probably been.
Yeah, but the basic functions are like fear,
survival.
If you're out in the wild, you are going to kill to survive. If you're not, you don't need that. So you kind of just expect.
Yeah, because if those were to get, I don't know about the ones captured in the wild and then brought into captivity, but the ones born in captivity, I think would just die.
Yeah,
because they're not hunting. They
understand.
can't hunt.
Yeah,
he's still like, he has tongs and he feeds them, like they still bite and constrict to kill it.
Yeah,
with that instinct, but they don't necessarily know how to track, or I don't know if that raises questions or concerns.
Well,
yeah, we're on a whole tangent, but
I have some interesting. I feel like there's a couple possible mechanisms for that. One would be kind of the adaptation of the snake in this instance is like senses. So like for our eyes, when we go into a really bright room, pupils get constricted, get smaller, and we don't take in as much light. And what that looks like for us is it goes from it's blinding to, it's normal now. And if we go into a dark room, they get bigger and we can see after a few minutes. So in that same way, if you look at the same, gray background for a really long time, that gray background, and which is what we do a lot of the time on sheets of paper, is a white background. We ignore the white background and we only focus just the way our brains work. Mm-hmm. Exactly, the important details. So when a snake grows up around a human, they ignores that. Exactly. They're used to this stimulus, so it doesn't affect them in the same. It doesn't give them the same. Maybe the first time it freaks them out. The second time it freaks them out a little less. The third time it freaks them out not at all.
It's almost a learned behavior of.
Yeah.
But some of them, he has had, I think there's a king cobra on there he's had for 12, 15 years. And maybe it's not a king cobra. Anyways, he has had a snake for a really long time. And he still is careful because it's poisonous. And I think it does have it's learned that this guy's not going to try and kill me.
Sure.
But it's at the same time, this guy feeds me.
Yeah.
So
yeah, they could. It's hard to say if they could be that smart enough to
distinguish.
And they probably are.
I mean, so he also has alligator. He has or a crocodile, whichever one, and he always makes a sound before he feeds it to teach it that it's almost like what was that psychology?
Pavlov,
where he rings the bell, and the dog salivates.
Exactly.
Yeah, so he has that kind of sense with those alligators. And Keaton, you are right. We're on a very far tangent, but
nope. Yep. I'm here.
The other possible thing that we've learned about that relates back to Keaton would be epigenetics.
Yeah.
So imprinting of genes. So imprinting, we pass our genetic information through just the nucleotide sequences, which is the DNA itself, but we also pass it through which genes were activated in your parents.
Yeah.
So and your mom might have shut off a certain gene due to some adaptation. So a baby's born with that gene shut off or on.
Yep. It's so I love epigenetics. I the idea that your skin cells and the cells in your eyes have the exact same genomic information of the exact same DNA, but the way that they're repressed and expressed is what differentiates them. And I think that's like really the key to a lot of saving ourselves from a lot of diseases, because it's almost like an idea that you could reset this biological clock on a lot of diseases, because surely in the neurons something is off with the epigenetics whenever there is like a feedback loop of creation of the plaques that cause Alzheimer's. So there's got to be something misfolded, misexpressed, and when we can figure out how to do that and differentiate and control epigenetics, I think we really take out a lot of diseases. And
they're working on it.
Yeah.
With and this might be too boring, but
no, I love this crap.
With histone modification, you can acetylate or methylate histones, and that both of those, the acetylation pretty much always opens up, if I remember correctly, the DNA. So you would open up more genes, or it would be more likely to be transcribed. But with methylation, I believe it can either open or close.
Yeah.
So
mostly close, I think, but in some cases it's
there is the two different methylations.
Oh,
the
really?
DNA methylation is DNA methylation itself always silences.
Always silences.
They call it irreversible, with quotes, because they don't know. You probably
can't always say always. You can never say always or never in biology.
Yep.
That's interesting.
So are you talking about turning genes on and off, I guess?
Mm-hmm.
Yeah.
So I saw, this was a long time ago, they were doing kind of turning genes on and off, and it was almost like dinosaur research, but with chickens. Because chickens don't have feathers on their legs. Their scales.
Oh, yeah, yes.
And so they can this is way beyond me, but they can turn that gene on to continue to make feathers for the legs. So you can have chickens.
Yeah, it's like the differentiation of our skin cells, or whenever you are forming as an embryo, the differentiation of your different organ systems. And it's fascinating. It shows how complex we really are whenever you think about how in tune everything is as it's forming, and especially in the womb. It's dang, I lost my train of thought.
So, how far? When will that be? Will that ever go to human trials in that kind of sense? That's probably like playing God kind of.
I don't think it's like playing God. I think especially
we're going to eliminate these diseases
from a religious perspective, God gave us the ability to do all these
free
things.
Will, or if you believe in
free will. Yeah, sure. I believe in free will completely because of that. But we have the ability to do this. It's not like it's the
11th commandment: Thou shalt not
edit their nine genes. But I don't know. Have they talked to you more about trials with actual changing the expression and repression of?
Sure. So not really on the differentiation thing. So I don't think they've tried really to like turn a fully
Put an eyeball on your
right,
arm.
Exactly. I don't think they've done that. And in fact, they actually tell us that you can't. They tell us that you can't.
You can't do it in vivo, but
Right.
you can definitely take a skin cell and change it into a cardiomyocyte
right.
in a tube.
And that's what they say. You can't do that.
Yeah.
But I guess you probably can. But anyways.
They probably just want to discourage it.
Well, it would be really hard and probably not make much sense.
Yeah.
Most of the time. But your body does that automatically. Certain cells, like in smokers, the lining of their trachea actually changes to a different form of cell that's more robust because they're just exposed to stress all the time. But the way that it does that is by changing the stem cells in the epithelial tissue. So
yeah. So it's not really like this idea is not we don't want to different if there's a disease, we don't want to differentiate our neurons into something else. It needs to stay a neuron.
Yeah.
It's just like what is the function of this neuron that is off, that we need to change that function. How do we personalize this? Because it's different in almost everyone. There's not going to be a universal disease set. It's always going to be different. We can look at like what microRNAs are overexpressed in this individual and how do we knock those out, or how do we bring the other microRNAs up. And there's a lot of other mechanisms. MicroRNA is kind of the only one I'm
familiar
with right now.
Well,
but then
go ahead, sorry.
But then there's the whole side of replacing our dying or dead or diseased cells with
Healthy
new
healthy
cells. Like taking out skin cells or bone marrow cells or whatever, differentiating them in vivo or in vitro and putting them back into, especially like a heart, because it can't divide, the cells can't divide, and whenever you have a myocardial infarction,
sure,
you have a bunch of dead cardiomyocytes there. How do we? The only treatment to me is we have to replace them. If they're dead, they've got to be replaced. And so, at some point, you have to be able to get the new cells synchronized and in the right place, which is almost impossible, I feel like.
Right, but I can tell you what they have done with this, and
yeah.
So or maybe are trying to do. We haven't actually talked specifically, but so in a lot of cancer cells, they are cancer cells because of epigenetics, because something has been switched on that should have been off, or vice versa. So a lot of the time, so what they'll do is cancer cells will turn off genes that will lead to apoptosis, which is this programmed cell death. So basically it's saying, you can't kill me now because I turned off my kill me gene. Because every cell has like a panic button, that big red button, like do not press, but they do press it all the time if they're getting sick and they can sense that. So cancer cells turn off the red button. They disconnect the power.
Yeah.
And so something that a lot of these drug targets have been looking at is to this histone modification I was saying earlier.
Yeah.
To disrupt that process somehow. Basically open up the genome more so that more genes are expressed. And while that would express, probably more oncogenic, which is more cancerous genes, but you're probably going to turn on a gene that leads to the cell death.
Yeah.
So that is a target, and
that's interesting.
I think that's shown to be at least slightly effective. But
better than what we've got right now for most
probably
cancers.
And the problem, one big problem with that is obviously that happens to every cell in your body. It's not specific.
Yeah.
So, and the what they say is the hope is, the cancer cells are more susceptible to death by this cause.
Yeah.
So your other cells should be okay.
Yeah. Yeah.
But that would be more susceptible to cancer in the future.
But it's kind of like
sure. Yeah.
So
I mean, I bet it would.
because you have more genes open, or
you're messing with the genetics of all your cells, and that's why certainly always causes problems.
Cancer is the most complicated disease we have. I mean, the thing is, I think if we didn't have the fear of cancer, we would have solved almost every single disease, because the problem or the solution to so many other diseases, the fear the fear of these solutions is that they'll cause cancer. So we don't inject cardiomyocytes into our hearts because we're afraid of a teratoma, which is a complete differentiation of what every single type of cell, and it's just somewhere in your body. It's a cancerous tumor pretty much. And I think if we could ever solve cancer, that would every other domino would fall in real quick right after that.
And back to
That's interesting.
telomeres.
Yeah.
In cancer cells, they're a lot of them are they don't ever die because they activate telomerase. Thank you. Telomerase, which basically regenerates their telomeres. So, like some drugs are trying to target, some companies are trying to target telomeres. Say that again, please. Telomerase as a target for living longer.
Yeah.
And maybe that is something to look at, but
people actually, there's like stupid companies that sell telomerase supplements. It does literally nothing.
but if it did do something, I'd be terrified because, I mean, the trade-off to that is, cancer cells are immortal, but they're cancer.
It's really cancerous.
Just want to turn into a cancerous blob, then go for it. But it's a scary thing.
That really is. Did you actually, both of you, did you hear about the guy in Edmond who had, like, I think stage 4 lung cancer, was given a very short amount of time to live, and he took a dog dewormer, and it saved his life.
I think I remember you saying something about
That's
that.
serious. This is like a few weeks ago.
I remember you saying something about that, but I don't.
Apparently, it's kind of like an underground, not treatment, but it's not an underground treatment, but like it had cured someone who had said it on the internet, and so he saw it. I mean, obviously he's desperate. He's looking everywhere, and so he tried it, and it worked. And now some scientists at OMRF are starting a program to study this dewormer. It's an anti-parasitic drug, so it's fascinating because it targets the microtubules, which are involved in cell division, and it's obviously in cancer you have an incredible amount of cell division.
So why haven't they looked at that before?
I don't know, because it's in dogs. Like it's like the whole idea that like metformin, like all these drugs that we have had that have been effective in a certain disease, we don't even realize the mechanism behind them, especially old ones. We have all these old compounds that we never really knew the mechanism. We're like, oh, this kind of works. Let's throw it in people. And now we're like, oh my gosh, this might be the holy grail of medicine with when it comes to aging. We're delaying everything. But I think there's so many compounds that we don't understand that we could utilize because they're safe, and if people are using them. So, but I don't know. I just was wondering if you had heard about that. It's
better
a crazy
than cancer.
Story. Yeah, everything's better than cancer.
No, haven't heard about that, but that is fascinating.
Yeah, I don't know how.
Well, I have some dog dewormers here if anybody needs them.
Apparently, the guy's like just gonna take on the rest of his life, like a low
because
dose.
He has to, or
no,
because
he's just like afraid, like
if it comes back.
Yeah.
So did it just kill everything? Like,
no, it targets cancer somehow.
So he just like, oh, I have cancer. I'm gonna take this, and then it just was the next week he was cured.
I don't know how quick it was or anything.
But it was like, I took this and now I'm cured.
Yeah.
And then he went to the doctor and said, hey, I don't need you anymore. I have this dog dewormer.
Well, now he's a science experiment. Like every doctor is watching him now.
Yeah.
So, but it makes me wonder, what is the targeting mechanism that whatever the dog dewormer is using to target the parasite in the dog? What is that mechanism, and what target is it? Because it's obviously something expressed on cancer cells if it's going straight to those cells.
But if it is the microtubules, which I recognize, like, you just kind of don't really know that for sure.
Yeah,
for sure.
I know it's microtubules is the mechanism that it's using it's deterring that, but I'm wondering what is targeting it to the cancer. Rather, we all your cells have microtubules.
Well, yeah, that's what I'm saying. Like, but it would probably be a cell that's dividing more
rapidly.
But, so you would think it would target your skin cells as well, and like epithelial tissue. A lot of things you wouldn't like. You do want to make more of. But I would rather have less skin cells than cancer, lung cancer, stage 4.
Yeah.
So
I don't know. That was a crazy story. I think a lot's gonna come out of that stuff, and I think.
Well, he's in Edmond. We're gonna get him on.
let's get him. He's in Edmond. So,
Dave, we're gonna have you next week, and we're gonna bring this guy in.
No, but I guess we could start talking about like other drugs, like the whole metformin craze. That
sure, I actually have not So I don't know the mechanism of metformin. Actually, so tell me, give me an overview. Explain like I'm 5.
Oh man, it's been a while since I wish I could go off on this as well as I could like 2 months ago, because it's been a while since I've reviewed it all. Metformin
you lose it.
is used. I know it's used in diabetic patients. Dang it, I can't remember. It activates AMPK, and AMPK is somehow utilized in the insulin response. And I honestly, I can't remember. You'd probably know better with the whole. I can't remember how diabetes is, the mechanism behind diabetes.
So the only thing I know about the mechanisms of diabetes are from.
Your insulin turns off.
Well, actually, so type 2 diabetes would be you're just insulin resistant. So your insulin receptors.
That's right.
Either they're tired is something that I've heard a lot, or they're just congested, or they get stuck. Something bad happens to them, messes it up. But the other problems related to that, we've learned a tiny bit about, is really like insulin itself can be converted into a lot of growth hormones.
Yeah.
And things that cause inflammation and cancer.
Yeah.
So inflammation causes cardiovascular disease also.
Yeah.
So those things, it's a nasty situation. But and we don't really, and the big thing is we don't really know what causes insulin resistance.
Yeah.
Besides, if you always have high blood sugar because you're always eating, but that's not true for everyone. So it's just really
it's a hard disease. It's a hard disease, but
super common hard disease.
Yeah, but I guess the idea behind this whole drug was that diabetic patients had been taking it and had been living, and they had shown reduced all cause mortality in just by a little bit, because they're still diabetic patients, but it prompted people to be like, whoa, what's going on? Like, they should be dying younger.
Well, like diabetic patients, they have some of the hardest medical struggles after, right? Once they're diagnosed.
Right.
Yeah, so it was kind of mind-blowing why they're surviving to, an average age, and why is there it didn't make sense to them. So they're starting all these trials. I think of the big trials called TAME or something. And they're just testing to see if normal humans can take this and cause them to live longer. So I mean, imagine if it works okay in diabetic patients, what is it going to do in a normal person? So
do you know how this drug came about? Like, and why people started taking it?
I think so. I think it was something with like goats and something with like goats and like Madagascar or something. somewhere ridiculous. And this is a plant.
They were just in
Madagascar.
What I'm saying, you're
if
right.
You're listening, shout out to you.
What is the big
Africa?
Easter Island.
That's the big thing next to Madagascar.
Where's Easter?
Are you talking about the Philippines?
I don't know. Anyways, it was a plant, and these goats were like living longer. So like, whoa, let's just split this thing out. And I think that's how it came about. I don't know. I feel like I heard it on a Tia show one time, a long time ago, and so they tested it out in diabetic patients, and it had something to do with the insulin resistance mechanism. And
well, imagine if everybody was taking insulin, how much more expensive it would be. That's a completely different topic. But
insulin should not be as expensive as it is, but that's another topic.
We'll talk about that another time.
But I think the whole AMPK thing is like, it's activated whenever you're fasting. So now there's this big group of people that are doing like week-long fasts, because this light AMPK, this cyclic AMPK activation seems to be really beneficial in autophagy. So autophagy is where your cells pretty much eat themselves, like kill themselves, but it's the bad cells that get rid of themselves, and then it's replenished with good cells. And
like what I was saying with apoptosis.
Yeah. It's a similar mechanism.
Apoptosis that actually packages up everything so that it can be eaten.
Yeah.
So into neat little.
So I know that fasting, like with dementia patients, has helped. The longer the fasting,
maybe that's why.
I say it helped. There's been studies that it has helped. The longer you fast between your last meal and the first meal the next day can really help.
This like intermittent fasting.
Yeah. Exercise or being active consistency, consistent schedules, consistent puzzles. Those kind of things help dementia patients. So I don't know if those. I mean, obviously, being active helps a lot.
Yeah.
In most facets of everyone's life. Maybe not like intense training, but being active, getting your heart rate up, fasting. And I don't know about a week long. I mean, that seems like a long time, but I was eating 3 times a day. Is that a societal thing or a cultural thing?
Yes.
Yeah.
1,000%. There's no way like humans 1,000 years ago could eat 3 times a day.
As long as you're not malnourished, so if you have your essential nutrients, which a lot of people don't have a problem with anyways, but there are people that have a genetic problem where they don't retain it as well, or they.
So I mean, a lot of people, those people take vitamins.
Right, but yeah, if you take the vitamins, then you're probably okay as long as you don't have something. Some people need to take a lot of certain vitamins to have any effect. But if you're on top of that and you're managing it, there shouldn't be a problem if you have the fat stored too fast.
Yeah.
So I could fast for a long
super
time.
skinny,
Nothing
oh my gosh.
I'm coming for you, Jesus. 40 days, 40 nights.
No, a man actually, there's a case study that I've read recently.
Yeah.
He fasted for over a year. It was back in the.
Was it this on 1,000 pound life or whatever?
It was
No, it was
back
it was
when experiments were like crazy.
years. It was decades ago.
To the extremes, yeah.
You could find this paper if you just Google "man who fasted for over a year."
Yeah.
Wasn't it Gandhi?
He lost like all of his fat, and he was way overweight or something. They just they gave him like water, obviously, and
Water.
and
They gave him vitamins
because
and
you need
minerals.
them.
And
But that's mind blowing. Like apparently, like did they say this at school about how he like lost all of his weight, but he didn't have the loose skin like most people that do that do?
I didn't learn about this in med school. I actually just read the paper on my own because we talk about stuff like this all the time. It's kinda, but I've seen it around and like people are skeptical, but I mean it's as good as any other data that we have.
It makes sense.
The paper has, it's peer reviewed. There are multiple researchers on the project. It shows pictures of the guy before and after.
Yeah.
I mean it's like fascinating. I think it looks really legitimate.
Yeah.
And
He's a real scientist
they took some
that
of
did
his numbers. And
Yeah.
I mean it was a team.
I mean, it makes sense. Like, we don't need to be eating as much as we do. It is completely a societal thing, and I'm not going to stop eating a lot because I just don't want to. But this idea that we have to eat all the time and it's healthy to eat all the time is not
3 square
real.
meals a day, yeah. Or
have breakfast. Breakfast is
most.
probably the least important meal of the day.
What's amazing how much we're learning, like.
Diet
My
and nutrition.
My parents always told me that, back in the 50s and 60s, they thought, smoking, it's not that bad. Like in some cases, people thought it was good for you. But now that, obviously we're finding out that it is extremely bad for you.
Yeah.
But it's amazing how much we're learning, and I feel like that's almost an easy, like after the fact. I mean, I guess hindsight's always 20/20, but from being born so much after. Smoking is like so dumb.
Yeah.
But for other people is like, oh, I'm gonna smoke because I can, and they didn't know the bad effects of it.
Well,
and we're learning like what was it? People said eggs were really bad. Was it? They said eggs were really bad for you, and now they're
really
saying
bad for you.
All the time.
Yeah. Nutrition is
literally every other day. You'll see a study. Eggs are the worst thing ever. Eggs are the best thing ever.
Salt is terrible. Salt is great.
You have to have salt.
Yeah, so it doesn't make sense. I don't know. Nutrition is one of the most BS research topics because you can literally just search for what you want to find and you are going to find it. There's too many variables. You can look up. You can say, oh, all these people eat red meat and they're unhealthy. Well, let's say red meat's bad for you. And it's complete trash because we don't know how they're living. We don't know what else they're eating. They could be smoking. Maybe they don't run, or maybe people who eat more red meat are just in general lazier people. Like there's so many variables that we don't apply when it comes to nutrition research, and it's mostly bogus. So, sorry, nutrition people, get your crap together.
Well, this is not about nutrition people, but something. Do you guys ever talk conspiracy theories?
A little bit.
Not on podcast, but we can.
I mean, on the podcast, but I mean, this is not like a really bad one. But the food pyramid is actually was not made by any like nutritional company. It was made by the agriculture
Industry.
whatever that
Oh my gosh.
the government agency, the agriculture.
Yeah.
Actually,
Department of Agriculture.
Thank you. Thank you. Department of Agriculture came up with the food pyramid.
So they were a little biased.
Well, there was just they put grains way down. Yeah, like we make a lot of grains. Let's put those biggest. We need the most grains so that we sell the most grains because that's what we make the most of. Like, and
So it doesn't go to waste.
there were a few things they had right. Like, yeah, you shouldn't eat a lot of processed sugar. So put that at the very top.
Yeah.
But like, what evidence suggested that grains are good for you?
Yeah.
Like, I don't think there was any. I think it was just we have a lot of it, and it is great for societally. Grain is a good thing because it
Pretty
feeds
much
a lot of
cured-
people. Exactly.
Most of world hunger.
Very few people die of starvation in the United States. They do.
I don't
they've
think
got
like
something-
anyone does unless there's
got
something wrong.
else.
Yeah.
So that's obviously great, but anyway, that was my soapbox about the food pyramid
Dude, I
and
kind of
why people think
I kind of believe that. Like,
it's true. I mean, the Department of Agriculture did come up with the food pyramid.
yeah, wasn't there some like also some
Ron Swanson pyramid to becoming a man.
one of the presidents in the 60s or 70s or something pushed all these new processed foods because it was cheaper and it was like, oh, this is the healthier solution, and it's literally just terrible
Just
for
garbage.
I would believe that
humans.
as well.
Yeah, but also like when it comes to nutrition, think about how many people think fat is bad for you. Like,
Yeah.
when it's arguably the best possible nutrient you can have.
Okay. I understand now a little bit why they think it's bad for you.
Okay, what's
Well,
the reasoning?
It's kind of because dietary cholesterol. Because cholesterol, they think it is you do uptake cholesterol in your intestines.
Yeah,
And other fats, so all your triglycerides and everything, and it's all correlated with your LDLs and HDLs, your cholesterol, which is also highly correlated with cardiovascular disease.
yeah,
So that's fine and good. I understand that. And they found that when people switch to plant-based diets, for some people, that helps.
yeah.
Not for, I wouldn't even say
Everyone.
it's for most people.
But is it the plant-based diet that's helping, or the fact they were eating just complete trash before that?
Could be.
Just
could,
a 180.
Yeah,
Could be that they're not even digesting. They're not uptaking any fat at all. So, and that's the problem with your intestines is just like, it doesn't actually matter if you eat fats or not, because the only way you secrete those triglycerides, those cholesterols, is through your intestines, through your liver into your intestines. That makes bile, and then you can secrete that, and that's how you get rid of those cholesterols. But a lot of it is taken back up in the intestines.
yeah,
And if you eat plants, you can block those receptors with the fatty like substances in plants. So that's one possible mechanism for that. But that doesn't work for everyone because people still make you make cholesterol, like your liver makes it, and it's important.
yeah.
So it's just a weird thing. I sort of, on one hand, I understand where that's coming from, but if you look at the data, it doesn't seem.
Yeah, the data is not. It's like the same thing to me. It's like the amyloid.
Well, it's just because
like
every person is different.
Well, yes,
Every person is
every person is different, but it comes back to the whole amyloid thing. Like, we've cleared out the amyloid plaques, but it doesn't work because it's not really what's going on.
causing it, yeah.
And people who go on why whenever our sugar consumption increased, our carbohydrates increased, why are we seeing so much more cardiovascular disease in
Exactly.
LDLs? Because
more LDLs. And
Yeah.
that's the thing. It's like it's more correlated with carbs and sugar than it is with fat.
with fat, which no people don't understand. Like
Exactly.
like you see on the labels, zero fat. It's like, yeah, because
candy.
Yeah,
It's
zero fat.
Sour
like,
Patch Kids. No
Thank
fat.
goodness.
Ooh.
I was really worried about the fat when I ate those bag of Sour Patch Kids too.
But can I? Sorry, this is a slightly off topic. But my dad doesn't eat fat in his diet.
Really?
That's like the diet he goes on. He's pretty fit.
Yeah, he is.
And I think that's a different mechanism, though. I really think it's just that fat gets caught up in your intestine. Like, it's slower to digest.
Yeah.
And I could be totally off on this one. I'll admit I'm out of my base here.
Yeah.
But there is evidence to suggest that fat is slower to digest, and I think that could possibly lead to just your intestines taking up more nutrients from your food that gets stuck behind it. But
that makes sense.
But that's my only and I only say that because my dad, that no fat diet seems to work for him, and that just could be one weird phenotype. But
yeah,
the whole thing is totally
that's mind blowing.
Yeah,
that's why nutrition's impossible.
Exactly.
Right there.
My dad eats a lot of carbs,
but it's a huge industry. I mean,
it is a huge.
Look
industry.
how many dietary plans there are, or people selling meals and saying this will make you lose weight.
Yeah, here's the dietary plan: just eat normal, healthy foods and not
McDonald's.
Yeah, no McDonald's, and you're gonna be fine.
And that's true for most people.
And exercise.
Yeah. And exercise, yeah, always exercise.
I'm glad I'm preaching on this, guys.
Well, something else I wanted to talk about was when you were talking about people that smoke because they didn't know in the 50s and 60s, but they knew by the 80s that smoking was bad for you, and a lot of people still did, even like pulmonologists. And I was listening to a story of a guy whose dad was a pulmonologist in the 80s, and he said his dad would smoke. He would be like looking at X-rays, like, you know, he'd come back from looking at all these, you know, or even
black lungs, basically.
Dissecting. Exactly. They knew what it caused, but it was just like these other, like they knew, but they still chose to do the bad thing, the risky behavior is what we would technically call it. So that's something that we're concerned about a lot in medicine now is
people doing it even if they don't care.
Exactly. Well, they know, but like, why? What's stopping them then from
risk versus
changing?
Reward? Am I gonna go on a completely super healthy diet for the rest of my life to add 2 years?
Or die in a car accident next week?
Well, and then that's getting into kind of addiction and motivation is like we have these stages of change that people go through. That I mean, they're not like this is not science. This is not hard science.
Yeah,
I should say
soft science.
We look down on, but so that science just says that, you know, some people are in this stage where they don't care. Like, they know the risk, but they don't care. Why? I don't know. But then people usually,
it's almost not worth the effort for a lot of people.
Well, yeah, and then sometimes they'll move into a state where they're thinking about it, like, you know what, I can't do all the things I want to do because I'm doing this behavior, and then eventually that might lead into they make a plan and then they change and then they maintain and then they relapse, basically, and those are like the steps and that they'll go through over and over again for a lot of people when they're trying to change a behavior. So it's just like that can be applied to almost anything aspect of your life. Like, why am I not studying? You know, and like for a while you're like, I don't care, I'm not studying. The test's not for 2 weeks.
Yeah.
And then you're like, wait a second, I need to be studying. And then you plan to study, then you study, and then you can either relapse into not studying or you can
keep
push
going.
through.
Well, it's kind of like the.
That's just human behavior.
It's almost like motivation. Now I'm really out of.
It is motivation.
It's
like, totally motivation.
It's like motivation is almost this positive feedback loop. So if you're really motivated and like, okay, it's like
this would be a great topic for Chance, honestly.
Really?
Yeah, he's read a lot about motivation and how it's
he is motivated.
Yeah, he's the most motivated.
Well, he says it's bullcrap, but
really
motivate like a motivational speaker.
Talk about it.
Yeah.
Well, a motivational speaker, yeah.
Or like he's like saying, I motivated you to do this, but
no, it's all intrinsic.
In 2 days, you're not going to be motivated anymore.
Yeah,
that kind of
you can feel fired up, but like. What is,
until hard change is
like Jordan
made.
Peterson always says something about like clean your room, like do the simplest thing you possibly can right at the beginning of the day. That way you've actually accomplished something instead of just leaving and not doing anything all day. Once you've accomplished something, you've kind of got this ball rolling. Like, okay, I'll clean my room. I'm feeling good. It's a productive day. Let's go study. let's go lift weights. Like
so, there's a YouTuber that I watch. I won't give his name because
is it me?
What?
Is it me?
No. Anyways, he was giving. He just vlogs, but his other channels are anyways, it doesn't matter. He talked about like just do the simple things in the beginning, kind of to that.
Yeah.
Like, okay, tomorrow I'm going to accomplish, or I have this long list. Let me do the easy things the first day. I'll do the. I just need to do one thing every day, whether it's to make myself better or to accomplish something.
Yeah.
And just do that one thing. Then that day was successful, and then the next day you do one thing and focus on that.
Yeah. What do they tell you in like med school about changing behaviors? I've always heard like the whole like it takes like I can't remember if it's 60 or 90 days until like you have a strong behavioral like habitual change in your like routine and what you're doing. Maybe it can be applied to addiction. I'm really thinking of like, because when I used to be really into working out and stuff, I would think of it as like, okay, I'm gonna work out 5 days a week, and it's really hard to do it at first. But then, say you've done it, you've stuck to this routine for 90 days, like it's life at that point. Like
it's a routine, you're done. Yeah. So that, I mean, we haven't talked about that necessarily.
Yeah.
Something we have talked about is you can't change someone who doesn't want to change. So
can't make the horse.
Yeah, you can lead the horse to water. So when you're like a lot of doctors, when they're interviewing a patient now, if they ask about smoking, no one's going to say, it's really bad for you.
Yeah.
Because that's just not effective. Some of them might still, but most of them are going to say, have you ever thought about quitting?
Yeah.
And then let them talk to you and say, so what do you know like about health risks or to you or your family or whatever? And then listen to what they say and like you move on. Like you say, okay, if you want change and you want to help, you want some help, then reach out and I'll help you.
Yeah.
These are the steps, and then they lead into the steps of what they're going to do.
Yeah, like, but it's mostly them that they're gonna change it. You're not gonna change someone, really. I think is the bottom line.
So my doctor said 30 days was the
30 days. I don't remember.
So when I was younger, I hated vegetables, but he was like, okay, choose one vegetable that you're going to eat every day. Like you don't have to eat a lot of it, but just eat some of it. And by 30 days, you can have that vegetable and it'll taste fine to you.
Yeah,
that was his thing. It was.
Did it work?
No, not really. But I didn't stay on it for 30 days. Okay. It was broccoli. It was like eat broccoli every day for 30 days, and you'll love broccoli in 30 days.
And that's the.
But I didn't stick to it.
The same point is
because I hate broccoli.
You didn't stick to it, so it doesn't matter how long.
I eat more vegetables now, though, guys. If you're concerned at home, I eat more vegetables now. I hope you're concerned. I hope you're not concerned. But I mean, I don't know if that was because I ate broccoli for 20 days or whatever, but. His timeline was 30 days, so I don't know if that's science or what. But
I don't think it's science. I think it's I believe it because we're humans that get into routine. Everything we do is routine.
It makes our lives
eating earlier. 3 days, 3 meals a day. That's a routine.
Routines make our lives 1,000 times easier.
Yes,
exactly.
So this was another. My dad talked to me about this a lot, and I might have even mentioned it before. But you make thousands of decisions every day.
Yeah.
You don't realize it. You make thousands of decisions every day. Make a couple decisions when you, like before the week, you start, say, okay, his example was church. Not to get off on religion, but his was every week you're going to decide when you wake up, am I going to go to church?
Yeah.
And he said, just decide right now, are you going to go to church or not for the rest, for this next month or year or for the rest of your life?
Yeah. So
he said, just make the decision now so you don't have to make it when you wake up.
Yeah, and it's like back to church. Like it was really hard, or it was hard to go to church after freshman year. Whenever I was never wanted to go, it was like easy to skip. Now, like it's hard to skip because it's my routine.
Yeah, and so making that decision early on, matters.
Yep, and that could lead back to motivation by saying once you have a routine, you no longer need motivation to do it.
Yeah, exactly.
But and conversely, you might need motivation not to do it.
Yeah.
If it's a routine like smoking.
Bad, yeah.
Like you're probably motivated to start smoking by something.
Yeah, someone in peer pressure. Peer pressure.
I don't know if it's peer pressure. I mean, it could be anything. It could be depression,
Yeah.
But then or anxiety.
Yeah.
Or fitting in or whatever. And I guess that could be those other two, but
it's all
something motivated you to do that.
That could lead back to motivation.
Why do you think people? I don't know. I feel like I'm pretty motivated and do a lot of crap every day. Why? I don't ever understand why people don't do anything. Like why do people well, why do people just want to sit and watch TV all day? Like, what is the?
Hey, watch what you say. Because they're motivated. I don't know.
That's something we're talking about in med school too.
Really, what are they saying? Because it's like always boggled me. Like, I don't want to. It drives me crazy to sit down at home and not do anything and watch TV. Or I mean, I started liking play Xbox, like playing Xbox now, just because I can play with friends. Like
The social aspect.
yes, like I was after taking the MCAT and stuff. I was like, what am I gonna do with my life now? So I went and bought Code Academy, and now I just go home and learn how to code after work every day. Like it just blows my mind that like how do people not get bored?
And so the lucky thing about going into medicine as a career is I don't actually have to know necessarily why they're not. I mean, it
Yeah.
would probably help if I could know, which would be an impossible problem.
Yeah,
That would help because I could maybe fix it. But what we like try to focus on thinking about is just like think about other things that might be causing this. So this person is different from you, and like why might that be? So maybe something really bad happened to them
yeah,
that has led to depression, which has led to lack of motivation, which has led to them sitting on the couch all the time, and then those problems kind of compound or whatever. Like the person misses their appointment because they don't have a car, because they're poor, because they're an immigrant, because they have 3 kids and they were not safe somewhere else.
yeah,
And that doesn't really solve the problem. It doesn't solve the problem of people not being motivated, not showing up for their appointments. But maybe you can help work with them through that to try to get them on the right path.
yeah,
Or if nothing else, at least you don't treat them with disdain.
yeah,
So understanding their situation will help you be nicer.
Well, I mean,
it's all about
and
empathy.
that could actually hurt, because what if they didn't have anything bad happen to them and they're just
Yeah.
lazy? I think the point is just like not to make assumptions, I guess. Not to say this person is fat because they're lazy, you know?
Yeah, yeah.
Because then you're not going to treat them the same as you're going to.
I hate that you looked at me when you said that.
Well, we know you're not lazy.
Yeah, I feel like I could use that because you are a motivated person. You're not lazy at all. You do more than I do. I mean, look at you, like doing this podcast. I never would have mustered the motivation to start up a podcast.
Well, I got it because Keaton wanted to do it. So
You're turning red. I think I'm embarrassing you.
I'm not.
I'm just kidding. But yeah.
It's so
But it just goes
interesting
back to the point that every person is different. I mean,
it is,
They
and
are,
I'm actually
indeed.
gonna say something about it. It is very interesting that like it's almost like the most motivated people have had something terrible happen to them, but the least motivated people have also had something terrible happen. So where's the divergence in the response to this?
just that go-getter
darkness,
attitude, I
I
would
guess.
think. I mean,
I
don't want-
why?
I almost
Why
want
they
to
have
say
that
like
attitude?
victimhood, but I don't know if that's...
No, but victimhood is not. I mean, it's a real thing, but it's like, why do they fall into it? Like, there's something before that.
Well, is there those people that are... So this happened to me, it sucks, and I want people to feel sorry for me. And there's those people, this sucks, I'm going to do something about it.
Yeah,
Those two separate... I don't know if those are both valid,
but why?
Well, I mean, that could be
there's something.
genetic.
Yeah,
Could be social support or like what you value as a culture. So
Yeah.
if you value spending time with friends and family and like just hanging out and stuff, I mean, that sounds really kind of mean. Not all culture. I don't know.
different cultures value different things.
Sure, if you don't really value career success, like
Americans do.
Asian cultures, like
Yeah.
a lot of Asian cultures are really like Indians, for example.
Yeah,
There's a lot of Indian people that their parents are like, yeah, you're going to be an engineer or a doctor, like, and that's you're set. That's what you're doing.
Yeah.
Whereas like my parents were like, do whatever you want, do whatever
Yeah.
makes you happy. Even though they did want me to be successful, they knew, or in their minds, it was more important to be happy, which is a cultural value.
yeah,
So if that is your understanding of the world and like what your culture motivates, and you say, I would rather just be happy than
make $100,000 a year.
exactly, then when something really bad happens to me, and I can just there's definitely utilization to complaining and saying I'm really sad this happened to me, because then other people see that and they come help you.
Social support.
Yeah.
Yeah.
So if you want social support more than you want to be successful, and for that bad thing to change, then maybe it's more beneficial for you to not respond that way. And I'm sure that's not the only factor.
Yeah,
that's just one example.
Oh, that makes sense.
But I mean, like those cultures, I mean, say you put you view your job as I'm successful based on what I have, like my job.
Yeah.
Right.
Those people are more likely to
exactly.
put in more hours to
Career success versus do you want kids?
Yeah, or
you
being
want
with
to
your
spend time with
family
your kids?
or whatever,
Yeah.
social things.
I mean, I agree with everything you guys just said. But I don't know. It still just like blows my mind that there's such a differentiation in responses to adverse events, I guess.
Well, I mean, it sounds like it all comes to almost how you were raised culturally.
Yeah, it's gotta be a societal, or not even a societal, but like maybe a family thing. What you saw growing up, like maybe how motivated, like you said, how your parents pushed you, or how motivated maybe your parents were. Like, oh, okay, I want to be like that.
So my parents, when I was younger, they said, you need to go to college to get a good paying job. That was just their obviously opinion. And they also said, if you want to keep up the lifestyle and have the things that we have, you need to get a good job.
Yeah.
And that was kind of that focus of what's a good paying job? What should I focus on?
Yeah.
And then other things fell into place of like being confident in math and science. So
yeah. So it's
I mean, if it was like get a good paying job and I wasn't good in math and science, then
business.
How would I have? Yeah. How would you come that? And I don't know if that's right, but
I think you would have found a high-paying job that didn't require you to do math and science.
Yeah.
Which is
but because you were just your family led my family led me that way.
You made a podcast like it's an entrepreneurship gene almost. But I think it's interesting. Like for me, money isn't. I want to be wealthy and successful, but it's not like the be all end all. I would rather be in a field like science that is much lower paying than being a medical doctor, but have this unlimited glass ceiling. There's no ceiling. There's no end to the potential. It's a low potential of being uber successful, but the idea of the climb to get to that point is more exciting than getting in just being a complacent, super successful rich person.
Burn.
Huh?
So
No,
a complacent, super successful rich person.
No. Not complacent, but it's like it's like I don't know. Seeing my dad is just a doc. Like he's been an ER doctor his whole life. Like doctors are ER doctors. Like
there's an idea of settling, even if it's settling for something
extremely
like that
high,
is you would really want.
Yes, like it's the pinnacle of our society, pretty much.
So my thought is, I want to make enough money where I don't really have to worry about it.
Yeah,
I don't have to live paycheck to paycheck, and then the other aspect is buy things that I want so that I can have fun and just not be limited in my activities, basically.
Yeah,
and safety. I mean, you're safe with money is security.
Yes, yeah. And so that security lets me do a podcast or go hang out with friends every weekend if I wanted to, or whatever.
Yeah.
So
absolutely.
That's my thought on that.
And retire.
Yeah. I would like to retire at 50 so I can play video games.
I don't want to retire either.
Let's go. See, we're both motivated.
Okay, well, I'm the opposite. I want to retire so I can so I can play video games.
I take back what I said about doctors. That sounded bad. It was.
Well, I hate doctors.
I didn't think you meant it that way. I didn't actually take it that way.
Okay.
I knew exactly what you meant, but I just thought it was funny.
Yeah. Okay.
Any closing thoughts? Or was that your closing thoughts?
That's my closing thoughts.
My closing thought.
Did you want to say anything?
Oh, yeah, actually. I think...
Is there anything we talked about? Yeah, okay, go ahead, sorry.
With that motivation, like your culture. So if there's something that I could change about society, if you gave me a magic wand, it would be for every culture to value health.
Yeah.
And if they did, I guarantee we wouldn't need as many doctors.
Health, and with health follows wealth, I think.
A lot of things, but...
Well, I mean, if you have health, success. You have... That's another thing of security. If I have good health and I don't have to worry about that, I'm secure in that I can do other things.
Sure. But if my parents had told me that the most important thing they wanted from me was not to be happy, but to be healthy. I mean, I might not be as happy, but I probably would be healthier.
No, I don't know. I think health like creates this like I said, positive feedback loop of happiness and motivation. Like if you are healthier, you have this energy to do things, and
Right.
I don't know. I completely agree with wishing health over pretty much anything else. Maybe
Yeah,
I'd
I'm not
say,
saying take it over everything, but
yeah,
just add it in there.
yeah.
Like
A
I
very
also
important.
want you to be healthy. I want
Yeah,
you
yeah.
to have these good habits and routines that
Yeah,
make some sacrifices, but are gonna help you
yeah.
in the long run.
Okay, well, thanks for coming down, Dave. Dave came all the way from another state to be on the podcast.
very
I wonder if you
faraway
could guess
state.
which one.
It's not on his
It's
chest.
cool.
That's my favorite state, coup, dude. But thanks for coming down. Thanks for being on.
Thanks for having me.
Good luck in med school. I know. How many weeks have you been in? 3,
Six.
7, 6. Wow.
6.
Dang.
Time has been
Already
flying.
He knows more than all of us combined.
That's not true. I'm a genius.
I'm gonna look back on this in
Cringe.
4 years and think I'm an idiot.
Well, I already
I
think-
think it's the same.
I already
That's not
think
the
you're an
mechanism.
idiot. I already think you're an idiot. So, but like I said, thanks, Dave, for coming down and being on here, enlightening us with your medical knowledge, and hopefully you look back and say, "Wow, I'm glad I went 4 years of med school because I was dumb, or I didn't know very much." And
I really don't. I wrote down a list of things that I do know a little bit about, so we could stay within my lines.
Yeah, but you'll never know. We'll never know everything.
Exactly.
It's
Always. Hopefully
it's
that
an
list gets longer. But
unlimited rabbit hole.
it will get longer. That's the point of school. But like I said, thanks for coming on. Don't forget to like and subscribe. Follow us on all our socials. If you made it this far. Oh, think about making T-shirts and maybe doing a giveaway, a gift card giveaway or something.
Giveaway. I hope I can win. Shoot.
You win every week by coming on the show.
I don't have any plugs.
What?
I don't have any plugs.
Follow David at Facebook that he never gets on. But anyways, thank you guys so much, and we're going to end it here.